Welcome back. In this video, I will review the dimensions and guidelines for the plate and axle that you're making in Unit 2. I will quickly review the dimensions of these parts and show you the features I use to make them. And then after I've given you the overview, I'll go into a step-by-step, more detailed explanation. So if you're feeling pretty proficient at this point, you really just need the beginning of this video, and the rest of it becomes a little bit optional. If you are new to CAD and you think I'm moving way too fast at first, hold on and wait for the step-by-step for the second half of the video. Okay, so this is what my bearing plate looks like. My bearing plate has 4 clearance holes for number 6 hardware. So I've got my mouse in the wrong place. 4 clearance holes here for number 6 hardware, and it has a hole that will be for press fitting a bearing, a sleeve bearing with a 3/8 inch outer diameter. This is a 1.5 inch square, and it is exactly 1/4 of an inch thick. So I'll go through and give you those sketches. So if I open sketch 1 and I go to a front view, you can see I have a 3/8 hole that is centered on the origin and a 1.5 inch rectangle, actually square. So if I was to show you constraints, you would see that these two have an equal constraint. When I made this sketch, I then used the extrude tool to extrude that 1/4 of an inch. And then I made another sketch, and this sketch allowed me to define 4 equidistant holes at 45 degrees from the horizontal here, and they are on a 1.25 inch a 1.25 inch bolt hole circle. So I have a couple of lines that pass through the origin. I have a 45 degree between these two lines, a horizontal and one of the lines. And then I could have put a perpendicular constraint. Looking back at this, I put in a 90 degree. There's probably at least 3 or 4 other ways to make this sketch pretty quickly off the top of my head. So don't feel like you have to recreate this sketch exactly. But I did create this sketch, and then I used the hole tool. The hole tool is up here, and I put in clearance holes for number 6 hardware at the intersection of those lines and the circle. And so that is the details of the plate. The axle I chose to make in a single sketch. You can see this is sketch 2 actually. So I had started drawing circles, and then I decided to do a single revolve step. So certainly you could extrude 2 circles, but here's what I made instead. I have my shoulder, which is 1/4 of an inch diameter or 1/8 of an inch radius, and it's 3/8 of an inch wide or along the axis. And then the outer diameter of the larger part of the axle is a 3/8 inch diameter, which is 3/16 inch radius. And the overall length of this shaft is 1 inch. It is a closed contour, and that allows me to make a revolution using the revolve tool. And I selected the profile, I selected the axis, and that gives me this shape. And so those are the specifications for the axle and the plate. The bearing you're going to download next fits in the plate, and the axle fits in the bearing. So those are how the dimensions of these 3 parts are related. So now I'm going to go through a little bit more slowly. So if you got lost, why don't we start with the axle, and we'll make this together. So we open a new part. I'm going to make a new sketch, and I'm going to put this sketch on the front or XY plane. That brings me into my sketch tools. So I'm going to use the line to draw a basic outline of the cross section. So I have a shoulder that goes up to a wider portion of my axle, and I'm only drawing one half of the cross section here, right? So this would extend down below, but let's say I cut it in half, or in quarters really, and I just wanted to draw the upper quadrant cross section. That's what that would look like. So I have my lines, and now I'm going to put in my dimensions. At any time the window doesn't seem to fit for you, there's this zoom to window button over here. So now I'm going to put in my dimensions. And this is a quarter total, which is an eighth in radius. So I'm just going to type 1/8. And then the diameter here is 3/8. So the radius is 3/16. And that's as simple as it gets. My lengths are wrong here. So I am going to put 0.375, which is 3/8 there for my shoulder length. And for my overall shaft length, I have 1 inch. And then I can finish the sketch, or I can go straight to my model toolbar and select revolve. It automatically knows the profile, and I need to give it the axis. So like if I was to select this axis, that's the wrong shape. So instead, I'm going to go ahead and select the bottom axis, and that looks a whole lot better. Okay. And if I want to see what this looks like, my ISO is in this corner. There's my isometric view of the axle. So I give that a save, and you're done. If you wanted to, you could sketch this circle, extrude it, sketch this circle, extrude it. That certainly is a reasonable solution. It just takes 2 sketches and 2 features, so I chose not to do that. Now the plate, let's make this one here. Actually, I think I'm just going to, let's see, where is suppress? Okay, so I'm just going to suppress that feature for a moment, and I'm going to come in to edit the sketch. So there were 2 steps to making this sketch. I'm not going to start from scratch here because I want you to explore it, and it is a pretty simple part until you get to the hole. So this one, it was a rectangle. So you select the rectangle, center it on the origin, and bring it out. That conveniently keeps the center of the part on the origin, which I find it to be an easy way to make these parts. Now, there is a way to show constraints. Here we go. Show all constraints. And so you can see the equals constraint between these 2 sides of the rectangle to force it to be square. And the way that you do that, I think I can delete it, is you hold down the control key and you select both of those lines, and then you hit the equal constraint at the top of the page. So now they are forced to be equal, which forces it to be square, and that gives me 1 less dimension to put in. Anytime you can use geometric constraints in your drawing to add a little design intent, it becomes easier to maintain that intent. And if your intent is for this to be a symmetrical square part, that is a good way to do that. And then I used the circle tool to put in a circle, and the dimension tool to make that a 3/8 inch diameter. So now I went to the extrude tool. I don't know if it's going to let me do that since I've already done my extrusion. So here, when I click the extrude, it should know what I want to extrude. You might have to select the inner part. For example, I could extrude that center part. I don't want to. I want it to be a hole. So instead, I just selected the inner area between the circle and the square. This is where you change the thickness of the part. And if you wanted to, you could change which direction it moves, as in which direction it's extruded, whether it's front and back, only front, or some mix And that gives us our plate. Now, I did the hole separately because Hole Wizard or this hole command allows me to access a standard library of hardware geometry. And if you want clearance holes for hardware, if you want tabbed holes for hardware, if you need a countersink for hardware, you always want to use the built-in tool that allows you to access those standard hardware geometries. So my sketch allows me to position the holes. So once again, I created a circle using the circle tool. And now you can toggle if it's for construction or not right here on your toolbars. Construction means I'm not going to use that geometry to create any sort of shape. I'm not going to use it to create an extrusion or anything like that. I'm just going to use it as reference. And I did the same thing for these lines. They're for reference. I'm not going to make anything with that line. I'm going to reference the point of intersection as a location of a hole. So I made a horizontal line. I made 2 lines, and if I show constraints here, you can see that this has a constraint to be horizontal. Both of these lines are constrained to pass through the origin, which means that they will be diameter lines, right? It's a single line that passes from one side of the circle through the origin to the other side of the circle. It has to be equal to the diameter. And then there's, like I said, I put 90 degrees here. Let's take that out. And instead, let's make these perpendicular. So we can control click these two and make them perpendicular. And I cannot move any of these lines, right? They are fully fixed in space. So this time you would finish the sketch. And then I chose to, in fact, I'm just going to delete the hole and remake it. So I selected the surface of the part and I chose the hole tool. And the first thing I usually do is select what kind of hole I need. In this case, it's clearance holes. If I wanted it to be something that the screw screwed into, it might be screw threads or tapped hole. Clearance hole here, I can change the size. English or US hardware is numbered until you get to 1/4 of an inch. 1/4 is a pretty standard hardware size. We use 6s a lot in the shop. That's the smallest hardware we use here. And so I chose 6, number 6. It tells me the outer diameter of that. So if you wanted to go check our drill chart, you can compare. And then the last piece is to select the positions. So I'm going to select the intersection of these lines and the circle. And that's all there is to it. So now I'm quickly putting in 4 holes. Oh, I just realized that my properties are off the page. So let me just quickly review that one more time. My video window is a little smaller sometimes than I realize. So let me escape out of this and we'll do it one more time. I selected the front face. I selected the hole. And then I was explaining that this is a tapped hole that has threads, and this is the clearance hole. I can change my size. I'm not sure if you saw the sizes as I was talking through it. There's the 1/4, 8, 10, 12, very standard hardware. 6 is the smallest we use in our shop. Here's the diameter of that hole, the clearance hole. And then select positions, and you saw me select the intersections, but I wanted to make sure all the settings in that property box are in your video window. Okay, so once I'm done, okay. Or there are advanced settings. I haven't used those yet. I don't think we'll need them in this class. So we'll click OK. And there is my finished product. Oh, that's not ISO. This one's ISO. Isometric is the corner between front, right, and top, by the way. That's the corner I keep clicking. So you save that and you're done your axle and your plate. And that concludes the instruction for the Unit 2 part models. In the next video, I will review how to download parts from McMaster.